Right, here we go. Homework sheet 10. First question, you have a straight line. You're asked for the line that's perpendicular to that, or the gradient of the line that's perpendicular. So first thing we must do is we need to take this line and write it as y equals mx plus c. Once you've identified the m, then you can turn it upside down and change its sign to get the perpendicular gradient. Question 2. We're told in the question that u0 is equal to 1. So work out what u1 is, and then work out what u2 is. So substitute 1 in here first of all, get your answer, substitute that back in, and that will tell you the one you need. Question 3, fairly simple. 3 times the first vector minus 2 times the second vector. Question 4, it's a cost graph. Now the number at the front is its amplitude, which we can get from the diagram. The number before the x is how many waves have we got. So if you just count up 1, that'll tell you how many waves that you have for that. Question 5, complete the square. So inside the bracket must be x add 4 squared. You can work out what the number is at the end. Question 6, use the limit formula, 17 over 1 minus a quarter. I'll let you work it out from there. Now question 7, the first one is probably make you think. From this circle, we know the centre is going to be half of negative 6 with the sign changed, which is 3, and half of negative 10 with the sign changed, which is 5. Now if we know the centre is 3, 5, that tells you what the distance is to the radius, because it touches that axis. It must be 5. So you know what the distance up to there is also 5. That will tell you what the point up the top here is, and if you know that point, then you know the equation of the line is y equals the y coordinate. Question 8, trying to find when these are perpendicular. So the dot product must equal 0. So you're going to do x times negative 3, 5 times 2, 7 times negative 1, and make all that equal to 0. So x times minus 3 is minus 3x, 5 times 2 is 10, 7 times negative 1 is negative 7, and it must equal 0. So you just solve that equation. Question 9, you know it's a log graph. Y equals log. Now there's a wee number that's going to go in here, and you also know that the log graph has been moved to the right so many places. A normal log graph, if you remember, goes through 1. This log graph goes through, so that tells you how many places it's been moved. So you can put that answer in here. You also know that a normal log graph goes through the point something 1, where the something is the base number. Now we don't have that in this picture because it goes through 6, 1, because it's been moved along. So if you put 6 into your formula here, so 6 take away whatever this number is that you found for the first part, that'll give you a number. That number matches the base number. Question 10, f of 2x minus 3. Now this is a finished graph. This is a back to front question if you like. We want to know what the graph started off as. So if it finished by moving down 3, it must have started off by moving up 3. And if it finished by doubling the x number, it must have started by halving the x number. So if you look at your graph that you've got here, the 0.64, it must have started up 3 and the x coordinate must have been halved. Well, there's your answer. Question 11, we're going to use the formula in this question that p dot q is the length of p times the length of q times cos the angle between them. Now the question tells us that it's an equilateral triangle and that the side is 3. So that's going to be 3 times the other side 3 times cos the angle between them, because it's equilateral, we know that's 60, plug it in the formula, get the answer. Question 12, calculate the ratio in which t divides SU. So we need to work out what ST is, we need to work out what TU is, and after you've worked out these things, you'll end up with two numbers, and there's some connection between these three numbers and these three numbers. The connection will be the ratio. It'll become obvious if you try that. Question 13. We've got a graph that crosses at x is -1, x is 0, and x is 2. So the cubic that gave that is y equals k times x add 1 for this part, x for this part, and x take away 2 for that part. Now you're also told in the question that it goes through the point 1, 2. So if you substitute 1, 2 in here, so if you put 2 in for the y coordinate and put 1 in for the x coordinates, then that will allow you to work out what the value of k is. Question 14, it's a cost graph. Now the cost graph initially would look something like this, but your cost graph has been moved to the right, and it's also been moved down. So the move to the right goes in here, the move down goes here. So you can look at the picture and it should tell you how much has been moved and how much has been moved down. Question 15. Now this is the only question that takes a lot of work. We're going to use this formula to work out the angle. So therefore we need to work out what A to B is, we need to work out what A to C is, we need to work out the length of AB, we need to work out the length of AC. Now once you've got these four answers, the top of the fraction is the dot product between AB and AC. The bottom is when you multiply your lengths together, and if you do all of that, you should be able to work out what the angle theta is. Question 16. Well, we know the coordinates of F are -2, 3 and 1. We know the coordinates of H are 16, -21 and 13. We know the ratio is 1 to 5. So if we do a little formula, that will tell us what the coordinates of G are. Question 17. Rewrite it as y equals, and then change the subject there until you get x equals. Once you've reached x equals, you can then write down what the inverse function is. Remember to change the y's to x's. And then lastly, number 18, probably the easiest question. F of g of x, put the g into the f formula, so we're putting this back in there. So instead of 4 x's take away 6, that x is getting replaced with the 2x plus 1. Tidy it all up and you're done.